Lumonics Wafer marking system, model WMDSC. This system is ready for operation right now. I'm running a job which is already preloaded, and it is selected for a wafer count of 25, and it's going to describe the name of bit service on each wafer. Now, the first screen contains a job where you can pick a job or delete a job, and the control is where you actually run the operation. So I want to mark all the wafers in the cassette here. These are 200 millimeter wafers. So I'm going to select mark all and click enter. Just in case if it is necessary to edit the job, it could be changed in this menu item. And these are the maintenance modes, where robot, aligner, marker, and each individual menu item here is for maintenance purpose only. And to exit the computer, you have to select exit in maintenance mode. So I'm going to run this. So right now the laser power is set about 2.5 watts. And after mark all is selected, the recipe will be uploaded, and as soon as the load lamp blinks, you have to press that so that the robot will start operating. So the wafer count on the screen becomes 0 after all the 25 wafers are processed, and the unload light starts to blink. And at this moment we unload the basket to check the wafer. Here is a processed wafer. This is the main power supply cabinet for the Lumonics laser marker machine. There are alarm indications here, which also exists on the front control panel near the computer screen. And in case if the laser is to be turned on in manual mode, both these switches as well as the switches on the control panel should be manual. And as soon as we turn on the laser, it will turn on the water circulation system, which is at the bottom of the cabinet here. And this is Q switch control unit for the laser. And the ESKI power supply here is for the krypton lamp. And the power supply control main circuit breaker is over here, and in manual mode we can adjust the current from this knob. And the DI water that is actually circulating in the laser head module can be refilled from this port. This whole cabinet is air circulated by using a blower fan at the bottom here. Coming to the rear side of this system, this control panel is connected to the main machine. The control panel on the rear side, we have there's a gas connection line here, and there's a vacuum pump connection. This is just a jumper plug. And these two umbilical cords are to be connected to the main connector, main system, and these are hardwired. These cannot be disconnected on either end. And the system will be shipped with these two chiller water inline valves will be turned off, and the system requires either tap water or a recirculation chiller in order to cool the circulating DI water in the heat exchanger. This system do not include the chiller or the vacuum pumps. Okay. This is the exhaust line connected to the process chamber, and which needs to be connected to a vacuum pump or for dust collection from the process chamber. Let's go inside the process chamber. So the exhaust line the base of this system is connected to this, which will collect all the dust. And this is the pre-aligner. And coming to this is the laser power control module, which is interfaced to the computer. The computer card file is over here, the two motherboards and the other interface boards over here. This is the robot controller, power supply and controller, and this is the pre-aligner controller. The process chamber has an interlock, a two-prong jumper that once you close the door, the interlock is enabled, and anytime opening this door will turn off the power of the whole machine. Did you get that? Okay. This is the main laser optical bench here. The cover here has two interlock switches on either end. This is the main laser optical bench. With the YAG laser, this is the main lamp housing, and the rod is inside this, and this is the rear end mirror and the front end mirror, and there are tubes here which are shielding the actual light, and there are interlock switches at the end of at either ends of this chamber. Invisible IR laser is in this area, and only at the time of maintenance these interlock switches can be disabled and turn on the laser by using these jumper plugs. No attempt should be made to turn these knobs. These mirrors are aligned and locked using the lock screws. Right now the system facilities are hooked up. I have turned on the vacuum pumps and the chiller water for the heat exchanger. And to turn on the system, you have to use this key switch. So if the vacuum is not turned on, this indication will show that the vacuum is not on. And in case if the airflow is not there, it will indicate, and also it will indicate the other water flow alarms and water level alarms, because there is a level sensor in the water reservoir. So if we want to turn on the laser, all the laser power and the safety door in auto mode, and I'm turning it on. We can also turn them on in manual mode as well. So this indication is for laser on indication. It indicates the laser is at this time on. The system is initializing. It starts with humming the robot. The robot is initializing. there are three pairs of indications and switches here. The load for the station 1, and this switch is for the station 2, and this one for station 3. And this switch is for moving the additional lens in the optical beam to reduce the spot size. So at any point of time, any alarm occurs, the alarm light will blink, and we are to silence that. You have to push this switch, and in case of if there is any fault, to clear the fault, we have to press this switch. So this is the first screen where the system is ready to operate. So we start with any job if we want to start with. So the first thing the system will ask is the username and password, which will be included in the manuals and on the system at the time of packing this machine. So there are several jobs already loaded on the system. So once you select it, enter it, and then so at this moment it is indicating that this job is selected in the queue. Just to demonstrate, I'm going to the laser power screen. Here it is indicating that the power setting is about 1.5 watts, and it is reading 1.5 watts. And the power supply set lamp current is about 29.6 watt. The laser power controller can be operated in different modes, either power control mode or LCS mode, and the details are explained in the user's manual. The lamp current should not exceed 38 amperes, and the repetition rate can be adjusted depending on the requirement. So to do the power check, I am using function key F5, and at this moment the power check is running, and accordingly the shutter doors will change. So to escape from this screen, press the escape button. To edit any job, we will go to the edit job screen, and here I'm going to demonstrate how to edit. The count is for the number of wafers, and the transfer is, it could be 1 to 1 or 2 to 2, which represents the transfer from and to station. So currently station 3 is selected, which is the extreme one on the right. The size of the wafer is 200 millimeter, that's what I'm running. The size is currently selected for 8-inch or 200 millimeter. This can be changed to a minimum of 100 millimeters or 4 inches. Now as soon as we go to the location, another window opens up, and here we can select the parameter, whether it is a graphics, a dot matrix, we want to print alphanumeric characters, or a barcode, and the height, width and spacing, other numbers have to be entered. And the aligner rotation, we can change it depending on where we want to. I can select 270 degrees, that will be with respect to the notch. And the X and Y coordinates here are the location of the marking where to be done. so which is adjustable here. So once we change the parameters, we save the parameters using F4. And now the job is edited. So at any point of time, we want to delete a job that was in the queue, we can delete it, or we can add a job in the queue. Now I'm selecting the operation in control mode. So when the load lamp starts blinking, that is when the system is ready for the transfer. And the cycle begins. In this operation, I have selected one wafer only. So once the cycle is finished, the unload lamp will start blinking and you have to reset the cassette or unload the cassette. So in the maintenance mode, on the robot calibration screen, these are the various parameters for the coordinates of the locations of the pre-aligner, or here for end 0 or Y, which is one end of the robot, and for the second end, these are the coordinates for the pre-aligner. And the station 1 coordinates are here, and these are in R is for the radius, theta, and Z is for height. Now these are already currently fine-tuned for these existing cassettes. So anytime a cassette is changed, these parameters are to be verified and follow the procedure in the manual in order to avoid any kind of catastrophic damage to the wafers while wafer handling is taking place.